Welcome back to another lecture from Organic Chemistry, and thank you very much for watching this lecture video. In this lecture, I will go through a preparation of amine compound. The first example that we'll practice will have sodium cyanide. Sodium, it will have a positive charge. Cyanide, it will have a negative charge, and because it has negative charge, it can behave as a nucleophile. Cyanide is a carbon attached to nitrogen through a triple bond. Nitrogen has a negative lone pair, and also carbon has a lone pair. Nitrogen has a 0 as a formal charge, while carbon is -1. So carbon is going to be the one that it will attack the carbon with the halide group or the alpha carbon, and the halide, it will leave the system. So what do we get in this case? Okay, remember this, that's right now we have 1, 2, 3, 4, 5 carbons. Okay, so we have 5 carbons, and I go 1, 2, 3, 4, 5 carbons. Now, the one that I highlighted is going to be a new carbon that is coming from cyanide, and it will be attached to nitrogen through a triple bond. So we get one carbon, one more carbon. Now we will have technically 6 carbons. So if I go back and label them from 5 carbons, now I have 1, 2, 3, 4, 5, 6. I ended with 6 carbons. So I got 1 new carbon. Next step, I will reduce this cyanide group, and I can use lithium aluminum hydride with say H2O. Next step, to reduce this group, and if I run X's of reducing agent like lithium aluminum hydride, I will get this compound 1, 2, 3, 4, 5, 6, and now I will have NH2. So I go 1, 2, 3, 4, 5, 6. So this one it will be hexane, and I'm gonna replace the E by an amine, so it will be hexamine, and that's gonna be the product. It's a primary amine, so we can use this technique to produce primary amines, but the reaction is happening through 2 steps, or running technically through 2 steps. Another one that we can use, we can start with the carboxylic group and treat it with thionyl chloride, and that's gonna simply get rid of the OH, and will replace it by chloride. So I get the chloride here, and we will have the carbonyl group there. Next step, we can reduce this one again with lithium aluminum hydride. And also, next step, we treat it with H2O. And if we run such experiment with excess of lithium aluminum hydride, and the carbonyl group, it will be gone, and also chloride, and this one is going to give us, forgive me, instead of this one, I should say NH3. Okay, NH3. In that case, we will get this. We will have, I go 1, 2, 3, 4, 5, 6. I go 1, 2, 3, 1, 2, 3, 4, 5, 6. So we have 6 carbon. We did not add any new carbon. Next thing is we will have just simply NH2 here. Okay, so this method also is going to give us a primary amine, but the difference between this method and the previous method, the cyanide is adding 1 carbon, okay, 1 carbon to the starting compound, and this one is not adding any new carbon. So whatever you start with, you will get it at the end, plus NH2 as a primary alcohol, primary amine. Okay. Another method that we can use to create the technique produce amine, we can do nitration. And nitration, we start with nitric acid, the presence of sulfuric acid. That's going to give us electrophile, and the electrophile, it will be such a thing, NO2 with a positive charge. This species is super unstable and it's going to attack the benzene ring, and it will replace H by NO2. Okay. NO2. Next step, if we take this species and reduce it and run a reduction process, we can turn this one to something like this, NH2. So that's another method to create or to produce primary amine, and by using nitration. And for the reduction, we can use hydrogen gas in the presence of surface a metallic surface like platinum, or say like nickel, or we can treat it with iron or zinc, the presence of acid, and next step, treat it with a base, it will turn it to NH2. So reduction of NO2 is going to give us a primary amine. Again, we got the primary amine. Now, what's the downside of the SN2 reaction? When it comes to SN2 reaction of amine, first step is going to, like, let's say you started with an ammonia. Ammonia is going after an alkyl halide. It will kick the halide out of the system, and it's going to give you system like, say, methyl amine. Okay, this is a primary amine, and it has 2 hydrogen plus methyl. Now, if I compare the starting compound versus the product is a stronger base. Okay, stronger base than ammonia. What's the reason behind it? The reason behind it, we replace hydrogen by CH3. CH3, it will donate electron density to nitrogen. So nitrogen now has higher electron density or partial negative charge on it. That means it will be a stronger nucleophile or stronger base than the starting compound. Okay. And that means it will not stop there. Then if we have excess of, let's say, alkyl halide, it will react with that excess of alkyl halide until it will turn it technically to quaternary ammonium salt. So I want to say this. When it comes to SN2 reaction of amines with alkyl halide, it's going to be hard to stop it on, like the primary amine. You can really just, say like the reaction is going to stop there, and that's going to be the major product. In fact, the reaction is going to keep moving until we run out of alkyl halide. And this is the downside of reaction of amine with alkyl halide. So alkyl halide, the reaction of alkyl halide with amine, it's not the best method to produce primary amines. Now, there are 3 methods that we can use. One of them is sodium azide. The second one, you can use Gabriel method, or you can go with reductive amination, and that one is going to give you a primary amine. And the primary amine, now you can use them and as a substrate and get them involved in any of this reaction to produce secondary or tertiary amines. I'm going to practice some of them for you. The first one is going to be the azide, and like we have sodium azide, this is going to be the reaction. So we have X is the leaving group. We're treating it with sodium azide. This one is +1, nitrogen, it will be -1. And what's the azide? Azide, this is azide. 3 nitrogen attached to each other through double bonds. Terminal nitrogens have 2 lone pairs, each one, and the central one has a positive charge. Okay, now we can kick the X out of the system to get this compound. So we get nitrogen here, and this nitrogen, it will be attached. Okay, nitrogen. Now we have double bond here. Okay. And this one, it has a positive charge. Okay, and X left the system with a negative charge, or you can say those 2 electrons are taken by X, and X left the system. Okay, that's going to be the starting compound. And sorry, the first intermediate. Technically, you can take that intermediate and work on it to turn it to a primary amine. Okay, let's go after this one. So the first step, we have an alkyl halide, and an alkyl halide, or any compound that any alkyl with a good Levy group, and we're going to treat it with system with sodium azide, and so we're going to kick the X out of the system. So X will take those 2 electrons and it will leave the system as X minus 1. Now, what will happen to R? Now, I want you to look to those 2 lone pairs. We have 2 lone pairs and nitrogen. Okay, one of the lone pair is there. And now, because X took to those 2 electrons, R is not going to have any lone pair. In fact, it's going to have a positive charge. So I will put R here and I will attach it to nitrogen. I use the second lone pair nitrogen to make a bond with R. Okay, now that I got this one, next step. Okay, next step, I can use like aluminum hydride and lithium aluminum hydride, and this one, remember that this one has -1 charge, and -1 charge, that means is a reducing agent, a strong reducing agent. Now, this one, it can actually go after that nitrogen, okay? And if we give hydride to that nitrogen, we will have hydrogen here attached to nitrogen. Okay, now, what will happen with these 2 electrons? Those 2 electrons, now, they will move to this nitrogen. And now, we used to have a positive charge there. Now we have a lone pair on this nitrogen. Okay, so from positive, we turn it to nitrogen with a lone pair. Next step, forgive me, next step, we can do rearrangement, okay, and say this lone pair, we're going to share it with second nitrogen, and nitrogen, the term nitrogen is going to take those 2 electrons, and it will turn to such a species. R attached to nitrogen. Nitrogen already has a lone pair attached to hydrogen, and now it's going to have another lone pair. And what else? Plus, okay, plus N2, and this one will leave as N2 gas. Okay, next step, if you have an acid, an acidic H inside the solution, that acidic H, it can be taken by strong base like N-1. This one, it will go after this H and it will give us such a system. So now we took H from water. We used to have 1 H, and now we are left with only 1 lone pair. Okay, plus we got OH minus. Now this amine is going to be a primary amine, and and this is the way that you can use the azide method to produce primary amine. And this is going to be the end of this lecture, and thank you very much.